Hey everyone, in this demo we're going to give Claude Code the same task with and without signadot and see how it does. The demo uses a microservices application called Hotrod. Hotrod has 4 microservices and a couple of pieces of persistence. It's a rideshare app that Uber originally developed, which we've extended with Kafka and MySQL. So that's the underlying application we'll be changing. Here are our 2 instances of Claude Code. Both agents receive the same prompt, to make a change to the location microservice. The agent on the left is standard Claude Code without a feedback loop. It can't actually verify the change in an environment. And on the right, we instruct the agent to use the signadot-validate skill, which makes use of signadot to provision a lightweight, ephemeral environment, which the agent can use to validate the change and make sure it's actually safe to ship. You'll notice both sessions are using medium effort with Opus 4.7. And right off the bat, on the left, the Claude Code session has already made the change, and it's starting to build the Go code and run the unit tests. And there it goes. The left side has declared success. Build and unit tests pass. So Claude Code is saying, okay, I'm done. There's no feedback loop beyond that. It's just testing that one microservice, and based on a change to a single file, it considered the change complete. On the right, it's made the same change and run the same build, but now it's asking us a question before it sets up the ephemeral environment for validation. With signadot, the environment only runs the specific things that have changed locally. The signadot operator handles routing traffic to the other services in the cluster to create a realistic virtualized environment for the agent. So far, we've changed the location microservice, so that's the only one that the agent will spin up. And I'm going to tell it to use Playwright automation to actually test the change end-to-end. That means Claude Code will drive a browser, clicking through the UI to verify the flow still works. Okay, so we ask it to use Playwright, and off it goes. Alright, now you can see it has set up a local location microservice, and it's validated that the change is actually in effect. We renamed a couple of fields, so it's just verifying that the format change has taken hold. And now it's going to use the ephemeral environment to drive Playwright from the front end, with the location microservice running locally in this session as a dependency. So everything else is coming from the cluster. The only thing we've swapped out is the location microservice. Okay, so now you can see the validation has surfaced a real downstream break. What it's saying is, the front end expects different field names, so the location microservice change is not safe to propagate. It's actually not safe to ship at all. So it gives us a choice here. Propagate the rename through to the front end, the React app, or just revert. It's giving us the safety of knowing that this change, if we pushed it, would break the overall application, even though it appears to pass local unit tests. Here we'll tell it to go and make the corresponding change to the front end as well, and then validate again using Playwright. Off it goes, making the front end changes. Then we see that it mutates the environment to add the front end as well. So now we'll have the location microservice and the front end microservice running locally in this session, and everything else, Kafka, the database, the rest of the dependencies, still running on the cluster side. And then we'll run another Playwright validation to make sure the golden flows aren't broken. Alright, perfect. The golden path actually passes, and Claude Code reports everything succeeds. It has made several changes, some to the location microservice, and some to the front end as well. So overall, when you compare it to the session on the left, the right session has made more changes, but it has ensured the change is actually safe to propagate across the entire application without breaking any contracts, and ensuring that end-to-end testing still passes, all with minimal intervention. Whereas the Claude Code on the left, which had no feedback loop, was quick to declare success, but without realizing that its successful change broke the front end downstream. It completed the change to one microservice, but it did not take into account the fact that this service is part of a larger stack, and there may be other things to validate. So that's the power of the closed loop. It lets the agent validate and verify its own work, and ensure that the code actually works as expected and achieves the behavior that you wanted. Signadot makes this possible in complex cloud-native apps built on Kubernetes with the low cost and fast spin-up time needed to support coding agents at scale.